The algebra of composite functions deals with words like inside function, outside function, first function, second function. Sometimes it's just better to do the algebra and see the pattern and then make sense of words such as these. Let's do that today. Let fx and gx be the two functions that we are interested in composing. And for the sake of this explanation, let fx be the first function, okay? The order is important. So fx is going to be the first one we evaluate. And on top of that, using the result, using the output of f, we're going to evaluate g on the output of f. Notice the terms that I'm using, all right? Output of f. So that would mean that this is the outside function or the second function. And this f here would be the inside function or the first function. Okay, so in that order, if that were the order, if f was the first function, then that would be the inside function, as you can see. G would act on the output of f. G would act on the output of f. Let's just describe it this way using Venn diagrams. Okay, this is something I picked up from a textbook. Lovely illustration. Here we go. So that's the domain or the input of f, okay? And this is the range of f or the output of f. So first stage is like the first step, the first function, f being the first function. Then the output of f is what gets used by g. G acts on the output of f to form g of f at that input. The input here was a. So a is the input of f. A becomes f of a, the output of f. F of a becomes the input of g, and the final result of the composition is g of f of a. Now that might seem too much, so let's take an example to make it simple. Here we have an example. Two functions f and g defined as fx is a linear function, x plus 2, and gx is a quadratic function, 3x squared plus 4x plus 1. And we have to find f of g of x, okay? So this is an example where the first function, the one that's inside, can you see that? The one that's inside is the first function. The one that's outside is the second function. So keep in mind the order. G of x, first evaluate g of x. Well, it's just in terms of x, so g of x is just as it were defined. G of x is 3x squared plus 4x plus 1. That's the first function, that's the first step. Let me bring this into the view of the camera. Now, we are going to find, as the question requires us, f of that, f of the output of g. So that would mean f of 3x squared plus 4x plus 1. All right, f of the output of g. You can see that? Now, how's f defined? F is defined as x plus 2. F of the input, f of an input is input plus 2. The input now is this entire term, 3x squared plus 4x plus 1. So it would just be 3x squared plus 4x plus 1. That's the input plus 2. Okay? So when you simplify that, that would simply come down to 3x squared plus 4x plus a 3. Now let's look at the second question. Here we have g o f of x. Now what that means, let me explain the notation first, okay? G o f of x actually just means g of f of x. All right, so in this case, fx is inside, that becomes our first function, okay? What's inside? That's the inside function, that becomes my first function, and g is the second function this time. Unlike the first question that we solved where g was the first function inside, can you see that? That's inside, g was the first one and f was the second one. So that clearly should help us recognize these notations. F of g, meaning g is the first, f is outside, that's the second. In this case, g o f, that's a slightly different notation. This literally means f is inside, so f is the first function. So let's evaluate this quickly, all right? So first we evaluate f. In this case, f is given as x plus 2. So we're looking for g of f of x, which would just be g of x plus 2. G of x plus 2. That's f of x. That's the output of f, all right? That's the notation, right? Yes. Now we're going to find g of that output of f, meaning this is the new input. This is the input for g. So now when you're evaluating g of x plus 2, that becomes my input. X plus 2 becomes the input. So we have to write this as 3 times the input square plus 4 times the input plus 1. That's the definition of g, right? 3x square plus 4x plus 1. That x must be interpreted as the input. 3 times the input square, 4 times the input plus 1. Now the input is x plus 2. So we have 3 times x plus 2 the whole square, 4 times x plus 2 plus a 1. Quickly, if you simplify that, you should get 3x square. That's a 4x plus 4. That should be a 4x plus 8 and 1. And that should be 3x square. 12x and 4x should give me a 16x. 12 and 8 is a 20 plus 1 is a 21. And that gives me g of f of x. And you can see clearly that g of f of x is not the same as f of g of x, which we saw earlier on. Now let's look at question number 3, which is f of g of 3. The difference this time is you got to find the composite at a particular value of x, okay? The first 2 cases we saw was just a general expression for f of g of x and g of f of x, okay? But in this case, we're looking at a particular value of x, which is 3, x is equal to 3. There are 2 ways to do it. We have already solved f of g of x here. We've already found that here f of g of x is equal to 3x squared plus 4x plus 3. We can just substitute x is equal to 3 and find the value of f of 3 like this. Let's do it. So f of g of 3 is simply replacing x by 3 in that expression. So it should be 3 times 3 square plus 4 times 3 plus 3, okay? And when you evaluate it, it should give you 3 times 9 plus 12 plus 3, which is 27 plus a 15, and that is 42. So this is one way to do this question. Another way to do the same question would be first find g of 3 and then find f of that, the output, the value you get as a result of finding g of 3, that would become the input for f. So let's do that, okay? That technique also. So first we find g of 3 as 3 times a 3 square plus 4 times a 3 plus 1. I think that was the definition of g. 3x squared plus 4x plus 1. Yeah. So let's evaluate this. And that will be 3 times a 9 plus 12 plus 1, which is 27 plus a 13, which will be 40. Okay, so that's g of 3. Now we find f of g of 3 by saying f of 40. Okay, so f of g of 3 is what we're looking for, as we did in the earlier case, but we found g of 3 first, and then you're just using that as the input for f. Okay, so f of 40 is the same thing as saying f of g of 3. And so f of 40, now the definition of f of 40 is just x plus 2, I believe that was. Yeah, it was just x plus 2. So f of 40 would just be 40 plus 2, which is 42. So both techniques are equally valid and they give us the same answer. Fourth question, f of x. That's kind of weird, f of x. Normally we say 2 different functions that you're trying to compose. This is f of x. Well,